Welcome to this video on green sand casting, a fundamental manufacturing process that transforms raw engineered sand and molten metal into complex geometric components.
Unlike ingot casting, which produces raw stock, sand casting is designed to create finished or near-net shaped components directly by pouring molten metal into a custom-shaped sand cavity.
Understanding this process requires mastering the vocabulary, from patterns and cores that define geometry to the cope and drag mold structure, and finally, the fluid paths and post-processing steps.
The sand used is a highly engineered composite. It must possess three critical properties: refractoriness to handle extreme heat, cohesiveness to hold its shape, and permeability to allow gases to escape.
To ensure success, patterns require specific modifications. They are made slightly oversized to compensate for metal shrinkage during cooling and incorporate draft angles to allow for clean removal from the sand.
When a part requires internal hollows, we use a sand core. This independent structure is placed within the mold cavity to act as a physical placeholder, defining the internal geometry of the finished part.
Here is the anatomy of a fully assembled mold. It features the cope and drag halves, aligned by dowels, housing the internal core and the cavity, which is fed by a precise gating and riser system.
The gating system is essential for controlling the flow of metal. It moves from the pouring basin down through the sprue, across the runner, and finally through the gate into the mold cavity. The riser serves as a vital reservoir. As the metal in the main cavity cools and shrinks, the molten metal from the riser feeds the void, preventing internal shrinkage defects.
The assembly of the drag involves 5 steps: positioning the pattern, enclosing it in sand, compacting it for strength, leveling the surface, and finally, extracting the pattern to reveal the cavity.
During pouring, the intense heat vaporizes moisture and binders. The mold's engineered permeability is crucial here, allowing these gases to vent through the sand walls instead of causing defects in the metal. Because the sand mold is sacrificial, it is broken apart after the metal solidifies. The component then undergoes fettling and cleaning to remove the gating systems and refine the surface finish. This process is incredibly versatile, scaling from tiny handheld components to massive industrial parts weighing several tons, and it is capable of casting almost any ferrous or non-ferrous metal. Sand casting involves a trade-off. While it offers immense geometric flexibility and low tooling costs, it often sacrifices precision, requiring post-process machining and resulting in a rougher surface finish. Ultimately, a defect-free casting is achieved by balancing geometry, material science, fluid dynamics, and thermodynamics. Success lies in the orchestrated harmony of these 4 core systems.